Hello everyone, I am Ataf Rahman. Today I want to talk about the electromagnetic spectrum. So what is the electromagnetic spectrum? So we have categorized our electromagnetic waves according to their wavelength, which is called to be the electromagnetic spectrum, starting from the shortest wavelength, which is gamma ray, to the visible light, which has a minimum wavelength of 10 to the power minus 8 meters, and to the longest wavelength, which is radio waves, which is 10 to the power 3 meters. So, what are the special characteristics about these electromagnetic waves, and why are they used in modern science and modern telescopes studying about astronomy and the outer space? So these electromagnetic waves have quite some unique properties, such as they have a property to carry a magnetic field as well as energy. So uh, this for these properties, these electromagnetic waves are used in telescopes in a group to give us a better image of what an object or presence is outside located by a telescope. So, what are some other characteristics that an electromagnetic wave has? It has a wavelength. That is how we categorize our waves in the electromagnetic spectrum. So, and these wavelength differentiates one wave from the other. As for example, visible light, it travels a lot, but it has a shorter wavelength compared to the radio waves. And compared to radio waves, gamma rays have an even shorter wavelength, which is 10 to the power minus 12 meters. So, one more specific property of an electromagnetic wave from the electromagnetic spectrum is that it has a property of carrying a certain velocity, depending on no change in whatever the medium is. So in vacuum, it will have the same speed. In an atmosphere, it will have the same speed as well. It won't differ depending on the medium it is traveling in. So I want to talk about a few of these properties used in um, our telescopes in a modern day. So, for example, telescopes use a number of electromagnetic waves such as infrared waves, radio waves, and gamma rays, X rays, visible light, also ultraviolet rays as well, to generate an image that is like more clear and visible, with properties such as density of the source and the shape of the source, the energy it is releasing. For example, if we study a star, we can learn about how hot the star is if these certain electromagnetic waves reach to the source depending on the wavelength. Because, like, as I have come across my study, I came to know about the Hubble Space Telescope by NASA. So, this telescope, what it does, it focuses these electromagnetic waves through lenses, and these lenses emit the waves towards the object, and when it comes back, so during this process, a lot of the waves are absorbed and blocked by the atmosphere and the other um, things present beyond the atmosphere. And when these different electromagnetic waves all together are received by the telescope, it creates a better image for us to study. And not only this specific telescope, um, also in contribution with the other telescopes, they can create a better image or like a better understanding for us. So like we cannot physically go near that object, but these electromagnetic waves are very vital for us studying about the presence of things beyond our atmosphere. And lastly, I want to talk about the most important thing, that is visible light. Without visible light, you cannot do anything, starting from waking up to communicating to studying. So, when it comes to studying about the things beyond our atmosphere, visible light gives us a basic idea, as we can see a few objects with our naked eyes due to the properties of the electromagnetic wave, which we call visible light, as it doesn't change its speed when it's coming through vacuum, entering the atmosphere, reflecting on us, the objects, and then in our eyes. So I want to say that it's a very interesting topic to talk about, and I would like to talk about it a lot more in some other videos. Have a good day, everyone. Take care.